Welcome to the Technology Addicts podcast. In this episode, we're diving into an article from the latest issue of Focus magazine, exploring the exciting world of sustainable transportation. Keeping an eye on all parameters. Sensors provide the information required to effectively control systems and ensure they remain safe. The sensors themselves are becoming increasingly efficient, more precise, and easier to integrate. Sensors have become an indispensable part of the networked and automated world we find ourselves in today. They are also key to providing the latest mobility offerings and technical solutions to ensure sustainable production and generate renewable energy. They are increasingly being used to improve the performance and efficiency of systems and plants, enhance safety, and save energy. For example, residual current sensors are important elements in charging stations. Sensors installed in the drivetrain of an electric vehicle monitor temperature, pressure, position, the properties of fluids, fluid levels, gas concentrations, current, and speed. What's more, to ensure the vehicle battery performs at its best and remains safe, sensors also transmit critical parameters for the heat and energy management systems regarding the condition of the battery, and to control and monitor humidity. MEMS technology, MEMS is short for microelectromechanical systems, has opened the door to smaller and smaller sensors, and designs measuring just 1.5 by 1.5 millimeters can now easily be produced. But they can be made even smaller than that, as researchers at the Fraunhofer Institute have used a micromanufacturing process to generate three-dimensional functional microstructures at wafer level. These measure a few tens to hundreds of micrometers and can be used to build MEMS sensors. These offer a whole host of benefits. Not only do they provide a robust design, long-term stability, and consistent quality, they are also highly accurate and less expensive, and they consume less energy. At the same time, more and more analog sensors are being replaced with digital ones. In other words, with sensors that transmit a digital signal directly. They are incredibly small, consume much less power, and can be used for many different purposes. Their biggest advantage is the information that they transmit. Whereas analog sensors only send a milliampere or voltage reading, which is converted into a measurement, a digital sensor can transmit much more than just the measurement itself. For example, the device status and calibration and adjustment data. Digital sensors can communicate directly with data loggers, and all communication with control systems or databases is also digital, meaning data transfers remain accurate. Another clear trend when it comes to sensor systems is the rapid growth in wireless sensors. They offer a number of advantages over wired sensors. For example, they can easily monitor measuring points that are far apart. The absence of wires means they are much faster and easier to integrate. Wireless sensors are crucial in areas such as smart grids in order to remotely monitor power cables and transformers. Here, they are used to monitor the cable temperature and weather conditions. Various systems can be used for communication purposes, from Bluetooth and Zigbee to Wi-Fi and cellular communication standards. As a result, it may be beneficial to obtain wireless sensors from service providers, as they can combine sensors and communication interfaces from different manufacturers into a single sensor module that is tailored to the application in question. Thank you for tuning in to this episode of the Technology Addicts podcast. For more exciting episodes, be sure to follow us on your favorite podcast platform and make sure to check out the show notes.